In this lesson, you will learn to simplify expressions involving sums and differences of radicals. Now, when you add and subtract radicals, the concept that we are going to use is the same concept that we've been using all throughout algebra up to this point, where if you are given an expression such as 2x plus 5x plus 7y, and you were told to simplify, what you would do is look for like terms, where you see we have a 2x and a 5x. Those are like terms because the variable is exactly the same. Whereas 7y is a different variable, so that is not a like term. So I can add 2x plus 5x to get 7x, and then you have the plus 7y at the end. Now, same concept with radicals. Let's say we had this expression, and you were told to simplify. To simplify, what you do is you look for like terms. And in this case, instead of a variable, we are looking for like radicals. So notice the first and the second terms, just like in the other example, they both have like radicals, where they both have a square root of 3 after the number. So these are like terms, and I can combine them just like we did with variables, where we have 2 square roots of 3 plus 5 more square roots of 3. So now I have a total of 7 square roots of 3, and then the plus 7 square root of 2 at the end. Here's another example where we see 4 square root of 5 and minus 2 square root of 5 both have the same radical component. So those are like terms, and I can combine those just like we can do with variables, where I have 4 square roots of 5 minus 2 more square roots of 5. So those combine to give me 2 square roots of 5, and then the plus 6 square root of 3 as well. Now everything must be identical. So like right here we see that 2 square root of 3 and plus 1 square root of 3 are like terms, but the middle term is not a like term. Even though the 3 is on the inside, just like it is for the other two terms, the index is different. Here there's a 3 for the index, which makes it a different term. It's not a like term. So I can combine those two I've underlined, and we have 2 square roots of 3 plus 1 more square root of 3 to give me 3 square root of 3. Now, sometimes, as in this example, neither are like terms at the moment. However, remember, we can simplify certain radicals if we can pull something out. So at the moment they're not like terms, but we can simplify both of these so that they will become like terms, and then we can combine. So if we factor the 12 and the 27 down, 12 would become 2 times 2 times 3. 27 would become 3 times 3 times 3. And now notice, for the square root of 12, I can pull out a group of 2's. I have one group of 2's, so I can pull out 1, 2. And over here, I have one group of 3's, so I can pull out 1, 3. And now, what I have is going to be a 2 square root of 3 minus a 3 square root of 3, and now they are like terms. Here, they both have a square root of 3, so I can combine. So I have 2 minus 3 gives me a negative 1 square root of 3, or just simply negative square root of 3. Here's another example like that. Here we see square root of 18 plus 2 square root of 3. The 18, you can factor that down. 18 becomes 2 times 9. 9 you can break down as 3 times 3. So we have 18 would equal 2 times 3 times 3. And then we have one group of 3's, so I can pull out 1, 3. And I'm left with a 2 on the inside. So I have 3 square root of 2 plus 2 square root of 3. And now in this case, they actually cannot combine any further because those are not like terms. They both have different radicals. Here's a square root of 2, here's a square root of 3. Those are not like terms. Now remember, we said that if we have a radical, it is best practice to not write the denominator inside of the radical. So here we have 2 radicals that are being added together, but both are fractions. So what I need to do is get rid of the denominator inside of the radical. So to do that, I can break apart both of the radicals, where for the first radical, instead of square root of 5 over 2, I can make it as square root of 5 over the square root of 2. So I break apart the radical into two parts, and the second radical, same thing. I break it apart, so I have the square root of 2 over the square root of 5. And then to get rid of the radical in the denominator, what I need to do is multiply by that radical in the denominator. So for this second fraction, I need to multiply by that square root of 5 for the bottom and the top. And then for the other fraction, I need to multiply by the square root of 2 to get rid of the square root of 2 in the denominator. So that's what I have on this next step right here. And then the square root of 5 times the square root of 2 can combine to give me the square root of 10, or 5 times 2. And then the bottom, square root of 2 times the square root of 2 would give me the square root of 4, which would just be 2. The radical would be gone. And then for the other fraction, this would become square root of 10 as well. You multiply the 2 and the 5. Here we multiply square root of 5 times the square root of 5, and that leaves me with just 5. So now I have 10 square root of 10 over 2 plus square root of 10 over 5. And to simplify all the way, I need to have a common denominator. I can put them together in one fraction. So to have a common denominator, I need to make the denominator a 10, something over 10. And the first fraction, to get from a 2 to a 10, I multiply by 5. So I multiply the numerator by 5 as well. And the second fraction, to get from 5 to 10, I multiply by 2. So I multiply the numerator by 2 as well. So now I have 5 square root of 10 over 10 plus 2 square root of 10 over 10. And then I can combine into one fraction where I add the numerators. And I have like terms right here in the numerator. So I can combine the 5 square root of 10 plus 2 square roots of 10 to get 7 square root of 10 over 10. And that is my simplified form of the radicals. So we've learned how to add and subtract radicals. We've learned how to use that in the context of fractions. And now we're going to show you how to multiply radicals. So here we see the square root of 3 times parentheses, square root of 3 plus square root of 6. We kind of already discussed this a little bit, but we're going to get into a little more detail here. But right now what we can do is we can distribute. So when it says multiply, we're going to multiply square root of 3 times both terms. And remember, when I multiply, what I can do is I can put them into one radical. So the square root of 3 times the square root of 3 would become the square root of 3 times 3. And then the square root of 3 times square root of 6 would become the square root of 3 times 6. So for the first radical, this would be the square root of 9, which would just be 3. And then the other radical, I can simplify further, where the 6 I can break down as 3 times 2. And then I can pull out a group of 3's. So I pull out 1, 3, because I have one group of 3's. And now I have 3 plus 3 times the square root of 2. And that is my solution. Here's another example. Square root of 2 times 2. Those don't really combine into one radical because they're not both radicals. But all I have is 2 times the square root of 2 for that first term. So the 2 times square root of 2, they don't combine into anything different. And then for the other one, square root of 2 times square root of 2 becomes the square root of 2 times 2, which would just become 2. So my solution would be 2 square root of 2 minus 2. Now here we see a fraction. And once again with fractions, the main thing is we need to get rid of the radical in the denominator. Okay, that is just best practice of writing radicals. And the 18 up here, we can also break that down as well. So to simplify, we need to do both of those things. So it does not matter which one we do first, but we'll start with the bottom, getting rid of the radical in the denominator. So just like before, to get rid of the radical in the denominator, I need to multiply by that radical. So multiply the numerator and denominator by that square root of 3. So now for the denominator, the square root of 3 times the square root of 3 would give you the square root of 3 times 3, which would just be 3. So the denominator is 3. And the numerator, we multiply the square root of 3 times the square root of 18, and the square root of 3 times the square root of 6. So now, what I need to do is simplify the numerator. So the bottom is good. Now I just need to pull things out as needed. So the 18 we could break apart as a product of 2 times 3 times 3. And the 6 you can break down as a product of 2 times 3. So now for the first radical, I can pull out a group of 3's. Because I have one group, I can pull out 1 3. And then for the other radical, I have one group of 3's as well. So I can pull out 1 3. So now I have 3 times, and then 2 times 3 gives me 6 inside the radical. And the other radical, we have a minus 3, and then a 2 inside of the radical. And then one last thing, notice that you can divide every term by 3. Because there's only one term in the denominator, I can see that there's a 3 here, here, and here, and divide every part by 3, which leaves me with a 1, 1, and 1. So what I have is going to be square root of 6 minus the square root of 2. And if you don't like to do that, if you're concerned with making a mistake, what you could have done is pull the 3 out, factor 3 out in the numerator, and I'm left with, in parentheses, the square root of 6 minus the square root of 2, and then cancel after the fact. Either way is fine. The only thing is be careful when you do it this first method, because many people will see the 3 and the 3 and just leave it like that. They'll cancel those two, but totally ignore the other term up here. So that only works, though, if there's one term down in the denominator. If there is something being added or subtracted down there, that would not work. Here's one more example where, once again, we need to get rid of the radical in the denominator, and we need to simplify anything else, like the 40 as well. So it does not matter which one we start with, but we're going to start with the denominator first. So we're going to get rid of this square root of 10 in the denominator. So to do that, I need to multiply the numerator and denominator by the square root of 10. So now for the denominator, square root of 10 times the square root of 10 would give you the square root of 10 times 10, which would just be 10. So the radical is now gone, and the denominator, or a numerator, sorry, on the top, you're going to multiply the square root of 10 times both of these terms. So we have the square root of 10 times 40 and the square root of 10 times negative 2 square root of 5. So the square root of 10 times square root of 40 you can combine into one radical. And then when you multiply the square root of 10 times negative 2 square root of 5, the 2 does not combine with the radical, but the 5 and the 10 can combine into one radical. Now, yes, you could multiply and then break things back down, but there's no need to multiply just to break it back down anyway. So what I can do is break down the 40 and the 10. 40, if you break the 40 down, you're going to get 2 times 20. 20 is 2 times 10. 10 is 2 times 5. And then the 10 is 2 times 5. So for this first radical, we have 3 2's and a 5 from the 40. So 3 2's and a 5. And then from the 10, we have 2 times 5. And over here, this 10 is 2 times 5, and that's where we see right there, 5 times 2 or 2 times 5. So then, to simplify the numerator, I need to pull out groups of 2 items. So here's one group of 2's, so I can pull out 1, 2. There's a group of 5's right there, so I can pull those out. Pull out 1, 5, because there's one group. And then there's another group of 2's right there. So I can pull out one more group of 2's, and I'm left with nothing inside of the radical. So that's just going to be 10 times 2, which is 20. Then over here we have a group of 5's, so we can pull out 1, 5. And so we have 2 times 5 times square root of 2, which would just be 10 square root of 2. So the numerator is simplified. Just take note that every term, every part of this fraction can be divided by 10. So I can factor a 10 out of the numerator, or I can just see this and divide everything by 10. I have 1, 1, and a 2, and that would give me a 2 minus the square root of 2. If you wanted to factor 10 out, you could, and do it that way, where you factor 10 out of the numerator, and then divide 10 by 10, and you'd still get 2 minus the square root of 2. So either way you want to do it is fine. Just be careful, once again, if you do it this first method, that you divide every part by 10. And that concludes our lesson for today. We will see you next time.